Okay, so the second application of integrals we're going to study in this unit is solving differential equations. So a differential equation, it sounds scary, right? It sounds very, very scholarly. But differential just means derivative. In fact, we've worked with these before, right? So a differential equation is just an equation that relates the function's derivative with the two variables x and y. Okay? So where we're going is solving these, and to solve one means to figure out what the function is. So which function has a derivative that can be described by this relationship. But right now we're just going to work on building our understanding of what these are. Okay? So this lesson is not that hard. This lesson's on slope fields. And this is the type of question where if you get this, especially in FRQ on the AP exam, you feel like you got lucky, right? Because this is sort of an easier piece of calculus content. So here is the slope field for this particular differential equation. It's going to look kind of crazy. The slope field. So think about what this might be. I'm going to start by labeling the points. So this is negative 1 comma 0. This is obviously 0 comma 0. And this is 1 comma 0. I'm going to label the rest of them. You guys know how to do this. So I've labeled the points with their coordinates. The slope field is a visual representation of this differential equation. Remember that the derivative dy dx is just the slope. And then x and y are just points on the graph, and you might see where we're going with this. So you can do the work here to figure out the slope at each point. I'm going to start with a very easy one, which is 0 comma 0. We'll zoom way in so I have room to work. So at 0 comma 0, the slope of this function is 0 plus 1 squared plus 0 plus 1, or times rather 0 plus 1 squared. So what I've done is I've plugged in my x and my y at this particular point. This gives me 1 squared times 1 squared, that's 1 times 1 is 1. And notice we have a rise of 1, a run over 1. Okay, so this is just a little line segment with slope 1. Okay, so when it asks you to draw one of these on the AP exam, all you're doing is you're just finding a bunch of slopes based on this differential equation. So we'll do a couple more. I'm not going to do all of these. I haven't given you very many of these to do because they're kind of tedious, right? Here, at 1 comma 0, well, dy dx would be 1 plus 1 squared. So I plugged in my x, and 0 plus 1 squared. So I get 2 squared is 4, right? And then 1 squared is still 1, so 4 times 1 is just 4. The slope of this particular line, this little segment, is 4. Okay? So this is, again, a visual representation of what this is saying, not necessarily the function that it comes from. It's just a graph of all the possible slopes. So here, obviously, at this point, we plugged in 0 and negative 1. And then negative 1 plus 1 is 0. We got a slope of 0. And that's actually true of all of these points. We're going to get a slope of 0 because y is always negative 1. And this factor is going to go to 0. And then here we plug in each point to get these slopes. Okay. On the AP exam, like, you just are sketching little hash marks, and they just have to go in the right general direction. So, like, vertical and horizontal have to be correct, but, like, you don't have to be super precise on, like, a slope of 1 versus a slope of 2. Okay? So this is quite easy. All you're doing is plugging in points. You guys have been doing this since 8th grade. I do want to note, I'm going to show you one more example, and I do want to note a special case that can happen here. So here is another differential equation and its slope field. And I want to note these vertical slopes. So let's see what happens here. So this is obviously the point -1, 1. And at that point, the slope based on this differential equation would be, well, let's see. So we get 2 times 1 plus 1 on top squared over -1 plus 1 on the bottom. So that, that -1 plus 1 on the bottom should be ringing alarm bells for you. Okay, I'm just going to leave that how it is. So -1 plus 1 is 0, right? So what we get is some nonsense on the top, doesn't matter, over 0. This is undefined. And this is really just a reminder. Undefined slope means a vertical line. So anytime you get something that doesn't work for that particular reason, you're going to draw a vertical little line segment in your slope field. You're also going to do a little bit of matching in this lesson. So here you're given a slope field, and it obviously has a bunch more points than the ones we were making. You have to figure out which differential equation it matches with. Your strategy, so what I could do is I could just randomly pick points and start plugging them into these equations and see what I get. But I don't think that's the most efficient way to do it. My suggestion here, and this will also be helpful on the AP exam for these multiple choice ones, strategy is going to be to start with vertical and horizontal slopes. Okay. So for example, I've already kind of highlighted that at x equals 0, I have vertical slope. So I know my differential equation dy dx is undefined at x equals 0. Notice I have two answer choices with x on the bottom, right? So it's got to be one of those, because those are undefined. Where x equals 0, I'm going to eliminate the other two. Okay. So starting with that series of points where the slope is undefined, eliminated two answer choices already. Then I might say, I know that the slope has to be equal to 0 at y equals 0, right? So that's this line here, y equals 0. Well, that's true for both, right? Because I plug 0 into either of these guys, I'm going to get 0 on top of my fraction, which makes the whole thing equal to 0. So that didn't help me much. Now you have to start kind of picking points. So 1, 1 and -1, 1 are good spots to look at. And I'm thinking that particularly because only the sign is going to change between the two, right? So I'll show you what I mean. So for this one, if I plug in 1, 1, I still get just 1, right? But if I plug in 1, -1, I'll get -1, right? So what that would tell me is that this little guy should be going down instead of up, right? Because that's at 1, -1, but it's going up as well. So we can probably eliminate that choice. Let's just double check this last one. If I plug in 1, 1, I obviously get 1 again. If I plug in 1, -1, well, I get -1 squared over 1, still 1, right? So upward sloping, upward sloping. Okay, so once you've made some moves to try to eliminate some answer choices, start to check individual points and make sure that they match. Sometimes it's hard to zero in on what exactly the slope of, say, like this line is, right? So I like to stick to the ones that are positive or negative 1, like kind of clearly these nice 45-degree slopes.